The synthesis of 4-methylcyclohexene is a classic dehydration reaction. Dehydration reactions are equilibrium reactions where you begin with an alcohol, you treat with typically a catalytic amount of acid in some kind of solvent, you heat the entire mixture, and you eliminate water, thus the name dehydration. So in this case, you're going to be making 4-methylcyclohexene. If you look at the structure of 4-methylcyclohexanol, you can dehydrate in two different directions on the six-membered ring. However, dehydration in either of those directions will give you the same result, the 4-methylcyclohexane. So it doesn't matter if you look at that structure which direction you go. As I mentioned, this is an equilibrium reaction, so you have the potential of doing a hydration reaction in reverse. So under these conditions, if you make some of the cyclohexene, 4-methylcyclohexene, you can potentially, with acid and water, add a water molecule back in and create the original compound. We deal with this possibility by removing the product from the reaction mixture. So we're using Le Chatelier's principle to drive the reaction forward. Remember, if you remove a compound from a mixture under equilibrium conditions, you drive the reaction to make more of that compound. So in this case, the cyclohexene compound is the product. If we remove it, we'll make more of it. So we removed it by distillation. So this is a distillation setup as part of the reaction. So not only are you refluxing, but you're also distilling. So when you look at the experimental setup, you would have a round bottom flask, then you would have a Hickman distillation head where you're going to collect your product, and then the reflux condenser or water jacketed condenser above that with cool water running through it. This allows all the product, the 4-methylcyclohexene, to condense down into the Hickman head, and then the operation in the lab would be to pull the product out via pipette. Then you analyze by IR, and what you're looking for in the IR is the difference between the alcohol starting material and the alkene product. So one of the key things with an experiment like this, and this applies for other experiments as well, is that you use Le Chatelier's principle to increase the yield of the product.